induction relays. In case of induction relays, we are having two electromagnets, and in between the air gap of that both of the electromagnets we are placing a disc of a non-magnetic material, that is nothing but the aluminium. Then when both of the electromagnets are energized, then for the first electromagnet the fluxes generated will be phi1, which are passing through the aluminum disc. Similarly, the fluxes generated by the second disc will be the phi2. As according to Faraday's law of electromagnetic induction, whenever the flux passes through that aluminum disc, and aluminum is a good conductor of electricity, that's why Faraday's law of electromagnetic induction takes place there, and an EMF is induced in that disc. But as disc is not forming a complete circuit, instead of it is having simply a closed surface, that's why it acts as a short circuited path, and due to that the EMF induced will be minimum, but high currents are flowing through the surface of that disc, which are called as eddy currents. So I1 is the eddy current produced due to the fluxes phi1, whereas the second flux will be generated by the second electromagnet, and due to that the second eddy current is produced in the disc, that is I2. The I1 lags behind the phi1 by an angle of 90 degrees. Similarly, the I2 lags behind the phi2 by an angle of 90 degrees. As well as between phi1 and phi2, the alpha degrees angle is there, and the second flux phi2 leads the phi1 by an angle of alpha degrees. That's why phi1 equals to phi1 max sine of omega t. Then the phi2 will be phi2 max sine of omega t plus alpha. So due to these two fluxes, we are having the relative flux, and the angle between that two will be the alpha degrees. So the two eddy currents are flowing through the circuit, and due to that the mechanical force is developed, and that we can easily find out by using the Fleming's left hand rule. So if phi1 and I1 are the current as well as the fluxes for the area 1, then F1 will be the force which is exerted by this in the aluminum disc. Similarly, for the phi2 as well as I2, as we know the direction of both of them, we'll find out the direction of F2, and this F1 and F2 are acting in opposite direction to each other. So as we know, the I is directly proportional to d phi1 by dt according to the equation. So if we put the values of phi1, then we'll get d dt of phi1 max into sine of omega t. So I1 is directly proportional to phi1 max cos of omega t. Then if we consider the I2, then I2 equals to d phi2 upon dt is directly proportional to d dt of alpha 2 max into sine of omega t plus alpha. So by taking the derivative, we will get I2 is directly proportional to phi2 max into cos of omega t plus alpha. Now F1 is directly proportional to phi1 into I1, and F2 is directly proportional to phi2 into I1. So the product of flux of one pole and the current in eddy current of the second flux, whereas the F2 is the directly proportional to product of fluxes produced by the second pole and the current eddy current produced by the first flux. So if we consider them, and as they are acting in opposite direction, that's why the net force F is the difference of the two fluxes. That's why F equals to F1 minus F2 or F2 minus F1 depending upon the values of them. So considering that values, we'll put the values of F1 and F2 as, so F is directly proportional to phi2 I1 minus I1 phi2. So if we put the values of the currents as well as the fluxes as earlier discussed, then we'll get F is directly proportional to phi2 max into sine of omega t plus alpha degrees into phi1 max cos of omega t minus phi1 max sine of omega t into phi2 max cos of omega t plus alpha, as it is the expansion of sine of a plus b. That's why we will get F is directly proportional to phi1 max into phi2 max into sine of omega t plus alpha minus omega t, as sin a minus b equals to sin a cos b minus cos a sin b. So from that equation we will get the force exerted on the disk is directly proportional to phi1 max into phi2 max into sine of alpha, where alpha is nothing but the angle between phi1 and phi2. So the F is directly proportional to phi1 phi2 into sine of alpha, where phi1 and phi2 are the RMS value of the fluxes